electrical energy into mechanical energy, involves a meticulously designed assembly of key components working together to produce rotational motion. The primary parts include the stator, rotor, commutator, in DC motors, brushes, bearings, and housing. The stator, the stationary part, is typically a laminated iron core with copper wire windings arranged in coils to create a magnetic field when energized. These laminations, made of thin silicon steel sheets, reduce energy losses from eddy currents. The rotor, the rotating component, is placed inside the stator and consists of a shaft with conductive bars or coils, often forming a squirrel cage in AC induction motors or wound coils in DC motors. When current flows through the stator's windings, it generates a rotating magnetic field that induces a current in the rotor, producing its own magnetic field. The interaction between these magnetic fields causes the rotor to spin, delivering mechanical power via the shaft. In DC motors, the commutator, a segmented metal ring on the rotor shaft, works with carbon brushes to switch current direction, ensuring continuous rotation by reversing the magnetic field polarity. Bearings, typically ball or roller types, support the rotor shaft, reducing friction and enabling smooth rotation. The entire assembly is encased in a housing, usually made of cast iron or aluminum, which protects the components, dissipates heat, and provides structural integrity. Additional features like cooling fans or vents may be included to manage heat during operation. For example, in a typical AC induction motor, the stator's windings are connected to a power supply, e.g., 230V single-phase or 415V three-phase, and the rotor's induced current drives motion without physical electrical connections, making it robust for industrial use. In contrast, BLDC, brushless DC, motors replace the commutator and brushes with electronic controllers, enhancing efficiency and durability, as seen in applications like electric vehicles, e.g., Hyundai Creta's hybrid systems, tying to your interest in trending cars. Each component is precision engineered to ensure efficiency, reliability, and alignment with the motor's intended application, whether in household appliances, industrial machinery, or automotive systems. For your NISH YouTube channel, explaining this construction with animations of stator-rotor interactions or real-world examples like EV motors could engage viewers in your autos and vehicles or education category. If you'd like a 30-minute YouTube script on this topic or a focus on specific motor types, e.g., for electric vehicles, let me know.